Okay, so these are the answers from the exothermic and endothermic reactions question sheet that you had last week. So we'll start down here at question number 1. Are the reactions exothermic or endothermic? Well, you can see that for every reaction, the temperature goes up from the start to the end. So we know that they are exothermic reactions. Explain how you know the answer to question 1. Well, because they all have temperature increases. What was the temperature change when 1 gram of ethanol was burnt? Okay, so we look at the table. Ethanol goes from 19 to 36, so it's just 36 minus 19, which is 17 degrees. Which fuel released the most energy when it was burned? Well, because each fuel was 1 gram, all right, we just need to look at the largest temperature change. So for ethanol, the temperature change we just calculated was 17. For paraffin, it was 27. And for white spirit, the temperature change is 23. So we can see that the most energy, because the highest temperature increase was paraffin. Why is it important to burn 1 gram of each fuel in each experiment? Okay, well, if, for example, I was to burn 2 grams of ethanol, then my temperature change would be much larger. And then I might think that ethanol releases more energy, but actually it's only because I've burnt more of that one particular fuel, so it wouldn't be fair. Okay, so the reason we need to burn the same amount is to make it a fair test. The temperatures of reactions of zinc, magnesium and nickel with hydrochloric acid were measured, the results shown in the table. Calculate the temperature change for the calcium reaction. So missing this one here, so that would be 38. Magnesium is more reactive than zinc but less reactive than calcium. So magnesium is more reactive than zinc, more than this one, but less reactive than calcium. Predict the temperature change for a reaction between magnesium and hydrochloric acid. So it's just going to be somewhere in between those two. So as long as you've written a number that's anywhere between 11 and 38, all right, not 11 or 38, but anywhere in between those two numbers, then that's fine. All right. And what name is given to reactions that give out heat? Those are exothermic reactions. What temperature change will be observed for an endothermic reaction? So you'll remember from last time that we had a nice summary of all the different properties of endothermic reactions, and we also said that for an endothermic reaction, the temperature of the surroundings decreases, so that would be a temperature decrease. Suggest another reaction which would give out heat. So another reaction which is exothermic, remember, because if I give out heat, I will see a temperature increase. So I can go up here and I can look, well, exothermic, yeah, releases energy to the surroundings, gives out heat, temperature increases. So any of these, combustion, respiration, so I would, anytime anyone asks me anything about like an example for an exothermic reaction, I always just go straight for combustion. Okay, because that's obvious, isn't it? You know that. You know that if you set fire to your table now, it will start to give out heat. So it must be exothermic. Okay, so let's move on to the next set of questions. All right, so you'll need to read, you will have read all of this measuring the temperature change stuff. I'm not going to go through that. And then we'll get to question number 9. A student investigated the reaction of magnesium with hydrochloric acid. A piece of magnesium was dropped into the hydrochloric acid. Use your notes from use of the acids to write a word equation for this reaction. So you should have, put it up here, magnesium plus hydrochloric acid makes magnesium chloride. Okay. And then the thing that a few of you forgot was to add hydrogen as well. So remember, metal plus acid gives you salt plus hydrogen. write a symbol equation for this reaction. All right, and remember, you can't just write MgCl for this. You need to be careful about how you write that. So we know that magnesium is Mg plus hydrochloric acid, HCl. Well, I know hydrogen's easy, that's just H2. And magnesium chloride, well, magnesium is group 2, so it's Mg2+. And chlorine is group 7, so it's Cl-, so I need it to be MgCl2. Okay? In your answer to question 9, indicate which substances are reactants and which are products. Okay, so we should have these guys over here. These are the reactants. And these guys over here are the products. Okay, that's easy enough. And next, which substances are elements and which are compounds? Okay, so elements are the things that only contain one type of atom. So magnesium, element. Hydrochloric acid, compound. Magnesium chloride, compound. Hydrogen, element. So even though there are two atoms in here, because they are both the same atom, we call it an element. Why does the mass of the substances decrease as the reaction goes on? Well, hydrogen is a gas. Okay, so when you do this reaction, you're making a gas. Okay, so you can imagine if you had, if I have a container with some hydrochloric acid in it, and I put in there a piece of magnesium, all right, as the reaction happens, a gas is going to be given off, all right, and that is my hydrogen gas. Now, if I'm weighing this, if this is all on a weighing scales, it's all on weighing scales, all right, then as my gas is released, the mass will go down, okay? So nothing magic is happening. It's not magically disappearing, magically getting lighter. All it is that because the hydrogen gas is given off, there's less stuff inside my container and the mass goes down, all right? But it's really important that you realise that mass is still conserved, okay? It's just that you can't weigh the gas that's been released, okay? So we would say here, why does the mass of the substances decrease? H2 released as a gas. Okay, the reaction is exothermic. Which two measurements would the student make to show the reaction is exothermic? So you just need to be temperature at start and temperature at end. Okay, or instead of end, we could have said we could keep taking the temperature, and then temperature at highest point. Okay, because if you do this, the temperature will go up, and then eventually it will start to go down again. Once the reaction is finished, and it starts to go back to room temperature. How would the measurements from question 13 show that the reaction is exothermic? Temperature would obviously increase. The student investigated how changing the concentration of the hydrochloric acid affects this reaction. Each test tube contains a different concentration of hydrochloric acid. The diagrams show the results of this experiment. Suggest one control variable. Okay, so control variable, you could have volume of acid. You could have temperature. Those are your obvious ones. Okay. Which test tube A, B, C, or D contain the greatest concentration? B. Look at it. Look at all those bubbles coming off. All right, so it's obviously B. Which test tube showed the smallest temperature change? So now we look, okay, well, which one's got the least reactive, the least amount of reaction happening is test tube A. All right, so that's probably going to have the smallest temperature change. So we have B here and A here. Okay, it's pretty safe to assume that more bubbles All right, more of it's reacting, higher temperature change. Fewer bubbles, less of it's reacting, smaller temperature change. Okay, some students did an experiment to find the temperature change when hydrochloric acid reacts with sodium hydrogen carbonate. The results are in the table. Describe as fully as you can the trends shown in the students' results. All right, so let's have a look. We are changing the number of spatulas of sodium hydrogen carbonate. So we're going to do the reaction 1, 2, 3, 4, 5, 6 times, and each time we're measuring a temperature change. Okay, and you can see that as the number of, or as the amount of sodium hydrogen carbonate increases, the change in temperature also increases. Okay, so that's what you would have to say. You would say, as amount of sodium hydrogen carbonate increases, what happens? The temperature change increases. Okay, now it would also be good, because it asks you to describe these as fully as you can, that you could say that once you get to 8 spatulas, once you get to 8, the temperature change doesn't increase anymore. All right, so the general trend is that more sodium hydrocarbonate, higher temperature change. However, once you get to 8, it doesn't change much anymore. Okay, and we want to know the energy transfer, the type of energy transfer of this reaction. So that's just asking us exothermic or endothermic, and we can see that the temperature is decreasing, 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 decreasing. All right, so you need to be look out here. This, you might get confused if you just looked at this column. All right, because this is change in temperature, you might think, oh, it's gone up by 4. It hasn't. It's gone down by 4. So these are endothermic reactions. Okay, now sodium hydrogen carbonate is used as a baking powder for making cakes. When the cake mixture is baked, the sodium hydrogen carbonate decomposes. The equation for this reaction is this. Balance the equation. Well, I've got 1 sodium here, and I've got 2 here, so I have to put a 2 there, and then I've got 1 hydrogen, but there's 2 because there's a 2 in front of there. 2 hydrogens, that's fine. I've got 2 carbons, 1, 2 carbons, and I've got 6 oxygens. 3, 4, 5, 6, so that's balanced. Okay, the cake mixture rises when baked. Use the equation to suggest why. All right, so the reason that the cake mixture rises is because you produce carbon dioxide gas. All right, so that's what happens when you make a cake or when you bake bread, is that you're producing gases. And the gases, they force, or they cause the mixture to expand. All right, and that's why if you look at a loaf of bread or a slice of cake, it's got what look like tiny little air pockets in there. Okay, and you can compare the original dough to the bread, or the original cake mixture to the cake, and the mixture or the dough won't have any holes in it. Okay, and then what happens is when the baking powder decomposes, it produces a gas, and that gas expands and creates those holes. And some loaves of bread, you can get really big holes in there. You can just take a look at it. All right, last 2. Sodium hydrogen carbonate is an ionic compound. Give 2 properties of sodium hydrogen carbonate. All right, so 2 properties would be, you could say anything like high melting point, conducts or does not conduct electricity in the solid state, or you could have said will conduct electricity as a liquid or in solution, or you could have said it's brittle or it's hard, anything like that. Okay. Explain why carbon dioxide is a gas at room temperature by making reference to its bonding and structure. So, its bonding is covalent. Its structure is simple molecular. All right. So there are weak intermolecular forces between molecules which do not require much energy to overcome. Do not require much energy to overcome. Therefore, I'm going to run out of space here, so I'll just say it. Therefore, low boiling point. Low boiling point, gas at room temperature. Okay? And finally, the quiz from last week, I asked you, there were 2 questions that people found tricky. One was, if I have 10 moles of chlorine gas, how many moles of chlorine atoms do I have? Okay, well, if I have 1 molecule of Cl2, that's 2 Cl atoms. If I have 1 mole of Cl2, that's 2 moles of Cl atoms. Okay, so now you should be able to see that if I have 10 moles of Cl2, that's 20 moles of Cl atoms. Okay, and the other one was if I have the reduction of sodium ions, Na plus E minus gives me Na, and I have 5 moles of sodium ions. How many electrons are transferred? So how many electrons transferred? Well, if I've got 5 moles of sodium ions, I need to add 5 moles of electrons. So it's going to be 5 times 6.02 times 10 to the 23 will give you the actual number of electrons. Okay, remember, you've got to be really careful with these questions. I think a lot of you, for both of these questions, didn't read the question carefully enough and got confused between, was it moles or was it molecules? All right, so you need to be really reading these questions carefully, because once you've read them carefully, it's quite simple, quite straightforward.